So that's how to deal with paths, but they're not the only part of an HTTP request. There's other things like parameters, query string parameters or posted data. Let's go back to start with a basic example. Here we're matching on HTTP GET with the top level path of /search. And assuming we have some kind of query string that we want to then take parameters from to search for, we could do something like this. We'll define an object to represent that parameter. To do that, all we have to do is say object, give it a name, in this case surname param, extends param. When you extend param, you give it the name portion of the name value pair. To then use that parameter, you can simply use an AND operator, like you'd use in an if statement, to say, I want to match on an HTTP GET that has a top level path of search and where the query string contains a name value pair where the name is surname and the value is Stokes. So again, that's not that useful because I'd have to have a lot of code to support all the different options available. But again, I can just insert a variable there and Scala does the magic. It takes my parameter in my query string based on the name of surname and then applies the value from that name value pair to my variable surname. I could also have the option of adding defaults. So when I'm extending surname, I can say, well, if there's no parameter with that name and no associated value, then set a default value. That way, my case statement will still match even if there's a parameter not found, and I'll just have a default value to deal with in my response. So now that I have a variable, it's going to accept any surname at all. Let's see what else we could do. Okay, here's an idea. Maybe there's a year range option on our query string where we can say the 2 years between some events. I can define a years param, extends the param class. Notice this time that it has int in there. This is how Scala does generics. You can specify a data type which is then used internally in Punk to return values of that type when doing the matching and assigning of values down in your case statements. I've just split this case into multiple lines now to make it a little easier to read. I'm matching on the same get search and I'm matching on a surname parameter, and then I'm matching on the years parameter. I can also specify a delimiter for Punk to use when parsing out my query string parameter, in this case a dash. And then to apply that parameter to my match statement, it means I'm going to match on a URL that starts with the top level path of /search and has a query string with a surname and a parameter years where the delimiter between two dates is a dash. And so what Punk is doing there is it's saying, I'll take that delimiter and turn the string into a sequence based on that delimiter. And by doing that, it means you can match on years param and then just specify the year from and the year to. And Scala is doing the work of actually, again, extracting those values out of the query string object and making them available to you in those parameters, ready to use in your response. So what about HTTP headers? Let's go back to a basic example again. Here we were matching on /article with an article ID on the URL. Punk provides extractors, which is these methods of extracting information from the object that's being matched on. One is available for every HTTP header that is defined in HTTP 1.1 spec. Here I'm going to match on a request where the URL is /article /something, but it'll only match if my accept language is set to EN. So if I set my browser to EN, then it's going to match. But again, that's probably not that useful. It's going to be nicer to be able to say, just capture that language value so I can use it to resolve properties files to display my page in the correct language or something like that. But there's a catch here. If anyone's familiar with the accept language header, it's not just a single value. What the HTTP specification says is that the preferred languages will be returned as a list with your most preferred language first, followed by others in your preference order. So matching on a single value will only work if the user has set their browser to one single language and doesn't have any others in their list. So how would we match on that then? Well, the accept language extractor supports a sequence. It's already broken up that language sequence that's passed from the browser into a set of values. If we use the underscore star, it means it will match on the accept language header that's sent by most browsers, but we can pick out that first preference language into a variable. Here's some other examples of headers that you might want to use. By using that host value, we could do some kind of virtual hosting within our system. Even though you've ended up at the same server, you may be coming from a number of different places. You may have got there via a number of different domain names. There's also the accept header, which is where the client identifies which data type it would prefer to get back. And so when creating APIs, we can say if the accept header is a certain thing, then respond in a certain way, and if it's something else, respond in a different way. So the pattern matching in Scala provides a way where we can define an endpoint, a URI for our service, and extract the path elements into variables, and specify the HTTP headers that are significant and the values that we want to extract from them, and specify any query strings or posted parameters and extract those values into variables. At the end of all that, we can have everything that we need to start to respond. We don't have to do additional parsing of any values from any part of the request. So what about the response then? How does Punk respond? Because just responding with strings isn't that great. How do we respond with some HTML, for example? Well, this is where Scala really just hands it to you on a platter. It supports XML inline, so what you're looking at here isn't a trick or a template. It's valid Scala code that compiles down to bytecode.